Hello and welcome to chapter 6. So today we're going to go over calculating correlation and regression in SPSS. Okay, now you can read this introduction to correlation and regression. I'm not going to go through all of it, but basically correlation and regression is all about two variables. There is no such thing as independent versus a dependent variable. They're both just variables. So in both variables, when one goes up, what happens to the other one? Okay, so this is correlation. You're not trying to establish a cause and effect relationship in correlation and regression. So the only thing you are looking at is when x goes up, what happens to y? Does it also tend to go up, or does it tend to go down? When it goes up, then when one goes up and the other one goes up as well, this is known as this thing, positive with direct correlation. Now when one goes up and when the other one goes down, this is a negative with inverse correlation. Okay, now when one goes up, the other one does not tend to move. That would mean that there is no correlation. Okay, so that is basically what it means. Okay, so now correlation analysis is to determine if there is a significant relationship between our two measures. Now, if we find that there is a significant association that do exist, we can then move on to do regression analysis. Now, regression analysis should be only followed after a significant correlation, which means that if there is no correlation, there is no need to go on and do regression. Okay, so you're probably thinking, what is a regression? Well, the regression is basically a best fitting line to the scatter plot of the correlational data. And then so what it does is it kind of predicts if you were theoretically have an X that is not measurable. Okay, that's not measurable by maybe the current technology or the current methods. So let's say if you have a theoretical value at x, what can you do to predict where y would be, given the fact that they are significantly correlated? That's all it means, okay? Now let's go and do our data set number 1. Okay, a principal in a large elementary school is looking over the attendance records of her teachers, many of whom are working moms. Some have only one child, while others have several children. The principal wonders if having greater numbers of children is associated with increased absence rates. To try and answer this question, she randomly selects the attendance records of 12 of her teachers who are working moms. She then notes how many minor children that are 18 or under, 18 and under, I mean, not including 18, I guess, under 18 years old. Okay, each teacher has. The data are represented below. So over here, you have teacher ABC all the way through L, and then this is the number of children, and this is the number of absence that they have. Okay, so now we have n of 12, as we said here, and then this is why we have 12 rows. Okay, okay, now let's go to the analysis. Open SPSS and start with a new data screen. Switch to the variable view. Okay, so we're in the variable view. Okay, and now what else? Now we are just gonna keep in the, okay, children, absences. Okay, so here we just get children, absences. Okay, now what's next? All right, decimals, of course, that's good, that looks good. Now what else? Okay, that's it. Let's switch to the data view. Okay, let me put this like this so I can just kind of copy it over without that much talking over back and forth. All right, 2, 5, 1, 3, 3, 9, 5, 13, 2, 8, 2, 4, 3, 3, 6, 10, 1, 6, 2, 6, 5, 7, and 4, 6. All right, now all the data are now entered. Okay, so once all the data, blah, blah, blah. Okay, to conduct the correlation, go to the data view, analyze, correlate, bivariate. Okay, analyze, correlate. Where is correlate? Let me make this a little bit bigger. Analyze, correlate, bivariate. Okay, now what's next? Okay, so we are putting both of them in that box. No, that was lecture. Sorry about that. Okay, so you just put in both of them in there. Is there anything else? Okay, so we have to check Pearson and also flag significant correlations on the bottom. Okay, Pearson flag significant correlation on the bottom. Is that it? Okay, I think that's it. So click OK. Now, what do we do next? Let's check to see if everything looks the same as your textbook. Okay, so we got the correlation value, we got the p-value, and we got the number of people. Okay, so does everything look exactly the same? Yes, it does. All right, so that means we did it correctly. Okay, now provide interpretation for the correlation. Okay, so now let's take a look at this. The Pearson correlation over here, this 0.65 is a strong correlation. It's a significant correlation. Okay, how do we know? Because we're basically looking at the p-value here over here, that is the thing that says 0.022, that is less than 0.05. That means that this is a significant correlation. That means that we basically, when one goes up, the other one also go up as well. Okay, so how do we interpret for this correlation? Well, we use R for representing the correlation. Okay, so the sample follows over here. Okay, so analysis showed a significant direct positive correlation between the teacher's absences and the number of children they have. R, okay, now let's take a look at this. R parentheses 10, where is the 10? Okay, so where do we get the 10? Okay, so the 10, we actually get it from 12 minus the number of the, so in this case, you always minus 2 instead of minus 1 that you see in all these others. So the degree of freedom here would be 10. Okay, so in correlation, you're always minus 10. Okay, and equals positive number of this. Okay, 0.65, comma, p equals 0.022. Okay, a greater number of children is associated with higher absence rate. Okay, now since we have obtained a significant correlation, we can move on to linear regression analysis. Okay, so let's see. First, minimize your SPSS output window and return to data view tab. Okay, we don't need this anymore. Okay, data view, where we are in data view already from the menu. So analyze regression linear. Okay, let's see. Analyze regression, where's regression? Linear. Okay, and then this pop-up window occurred. Okay, so the next step is to define the regression values. Okay, now move your predictor children to the independent box and your predicted value absence to dependent box using the arrow buttons. Okay, let's see. Okay, so we're over here. We are using wait, let me see it again. Okay, we are using the number of children as the independent, okay, and we are using absence as a dependent. All right, so does that look pretty good? Okay, now let's click on the statistics button. Now, what do we need to check? Model fit. Okay, so we need to check model fit and then estimate it. Estimates. Okay, I think we are good. Let's click continue, and then from data view, blah blah blah. Okay. Okay. Wait, hold on a second. I think we are supposed to hit this first, okay? And then we go back to this. Then we need to go to data view and then analyze regression and then curve estimation, okay? Regression, curve estimation. There you go. Okay, now let's see. These steps need to provide blah, 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 the formula for the regression line. Now another pop-up is going to occur. So let's put in children here, absence here, and then exactly the same as what we saw before. Okay, absence is the dependent. Number of children is the independent. Okay, are we done? Okay. I think so. Okay, click OK. Okay, so the curve fit and the linear is going to come. Okay, so let's see. So the model summary, okay, is telling us what? Okay, so the model summary is basically telling us this. All right, so we got children be removed. All right, so the model summary is this. So this is basically the exactly same thing that you saw before. It gives you the R and it gives you the R squared. So R squared is the variance accounted for. Okay, now let's take a look at the ANOVA for the A over here. And this is exactly the same number as over here that you can see. Okay, now the one that you need to pay attention to is the coefficient. So that would be the slope. All right, and then so the y-intercept is over here and the slope is over here. Okay, so basically that just kind of tells you everything that what you need to do. So this is very simple algebra. If you remember your algebra, it's y equals b plus bx plus a for a straight line, and so the y-intercept is basically tell you where the y where this is going to, this straight line is going to intercept at, for the y-axis. Okay, and the slope is just how steep it is. Okay, there's nothing to it really. Okay, now let's see what else. All right, so we're good. That's just basically exactly what it tells you over here. Let's see. Okay, so that's just very simple algebra. You can just brush it up yourself. I think that's about it. Yeah, I think that's it. I think that's it. That's it for today. Yep, that's pretty simple. Okay, we don't need to do this. Now let's do the practice. Let's do the practice problem. Okay, so below is a data set for your. All right, so how will you do this? All right, I'm just gonna exit this out. Actually, I'm gonna start a new data. All right, and then get rid of this. I don't need this, and then I'm gonna erase this. I don't need it. No. Okay. Okay, so below is a data set for your practice, for your regression analysis, blah, blah, blah. Okay, so scenario, a school counselor is worried about her students. She thinks that they might be a bit over committed with respect to their responsibilities. Many of them work and then they have to find time to study around all of their commitments. To better understand if there is a relationship between hours worked and grades, she gathered a sample of 10 students. She asked how many hours each works per week and then compares that to their grades on a recent math exam. The data follows. Okay, so how would you do this? Okay, so the way that you would do this in the variable view is very similar to the thing that you did before. So the work hours. So I think so. One thing about SPSS, it does not like space. So you need to put it in the under. You need to put it in an underscore instead. Okay. Now let's just put this decimals down here and then let's go to the data view. So 10, 82, 12, 95, 12, 91, 15, 96, 15, 84, 16, 87, 17, 78, 18, 90, 20, oh, sorry, 72, 25, 80. All right, now let's run the correlation and see what happens. So remember, go to analyze, correlate, bivariate, and then just put both variables in there. Okay, flag significant correlations, so we're good. Press OK. Now, what do we see? Okay, so the Pearson correlation, what we see is this number over here. So this is a negative 0.491. Okay, now what's the significance? So the significance is 0.149. Okay, now is this significant? Well, let's think about it. Is it greater than or less than 0.05? Well, it's greater than 0.05, right? So it does not reject the null hypothesis, which means that there is no significant correlation between the hours worked and the grades. So what do we do next? Well, that's it. We don't run a regression after this because this is a non-significant finding. And since there is no relationship between the hours worked and the grades obtained in class, you do not go on and do a regression. So that's it. That's all you need to know for this class.